Hello and welcome to the fourth film in our Floors and Ceilings series. In it, we examine the characteristics of solid reinforced concrete floors. Floors are always subject to bending stresses. This means that both compression and tension forces are at work within floor components. As you already know, non-reinforced concrete is a poor absorber of tension forces, and so reinforcing steel in the form of bars or mesh is embedded in concrete to improve its performance. As a result, the reinforcing steel bars, or rebar, should be placed at the specific points at which tension forces occur. In a non-cantilevered floor, tension forces occur at the bottom of the slab, and it is here that rebar should be positioned. The steel must be entirely sheathed in concrete to avoid corrosion. When designing and dimensioning a solid reinforced concrete slab, it is important to analyze the various factors that will affect it. This means determining the types of load that may occur, calculating the loads to be transferred, designing the load-bearing points, linear or single point, and deciding the span width and direction of the floor. Once these points have been clarified, it's time to calculate the slab dimensions. Let's take a look at the floor in the example illustrated here. The floor has a one-way span of 6 meters with no partition walls, is cantilevered, and is supported on linear walls. We can estimate the floor thickness using the following formula. 6 times 0.8 equals 4.8 meters. 480 divided by 35 plus 4 equals 18 centimeters. If it had to bear the weight of partition walls, it would be 20 centimeters thick. 4.8 times 4.8 divided by 150 plus 4 equals 20. In practice, however, the ideal load-bearing conditions of a solid floor slab that we have just seen do not always apply. Rising walls exert unintentional clamping forces on the floor, thereby creating a fixed clamp bearing. This clamping effect causes negative moments at the bearing point, which have to be countered by means of edge reinforcement at the top of the floor. Another important factor in designing solid floors, particularly in terms of cost-effectiveness and appearance, is whether they will be cast in situ or constructed using prefabricated elements. Slabs that are cast in situ require formwork into which the rebar is laid before the concrete is cast. Because wet concrete is even heavier than the subsequent floor will be, this formwork requires the costly and time-consuming erection of a supporting system. Prefabricated parts are produced in a concrete plant and installed on site, but have visible joints where panels butt together. Summary. Floors are subject to bending stresses with both compression and tension forces at work within their components. Non-reinforced concrete is a poor absorber of tension forces, and so reinforcing steel in the form of bars or mesh is embedded within it. In non-cantilevered floors, tension forces occur at the bottom of the slab, so that is where the reinforcing steel is positioned. Solid floors can be cast in situ or constructed using prefabricated elements. When designing and dimensioning a solid reinforced concrete slab, it is important to analyze the various factors that will affect it. These include span direction, bearing position, and the presence of cantilevered sections and partition walls. Our Floors and Ceilings series continues with film number 5. In it, we look at beam-type floors and ceilings made from reinforced concrete, steel, and timber.